Welcome to our last lecture, Trigonometry. We'll be starting on page 164 in the textbook. Trigonometry is the study of right-angled triangles. And we have a couple of formulas you're going to need to memorize. My first piece of advice for when trigonometry is you always draw a triangle. You always label your triangle. So our right angle right here is always labeled corner C. And directly across from the right angle is side C. Side C is also called the hypotenuse. And it's the longest side of the triangle, always. So across from my right angle is my side C, the hypotenuse. Angle A and angle B, those can be named anything. But the part that's important is across from angle A, I have side length A, and across from angle B, I have side length B. So when you draw your triangle, make sure you've got it all consistent. And I'll try and use A, B, and C in all our examples here to make it easier to keep track of. There's an acronym that people like to use in trigonometry, SohCahToa. And it's on page 164 down in your margin there. So, the S stands for sine. So when we talk about sine, the sine is equal to the opposite over the hypotenuse. And it's okay if that doesn't make any sense yet. So sine equals opposite over hypotenuse. Our next abbreviation is ca. So the C stands for cosine. Cosine is equal to adjacent over hypotenuse. And again, we'll go into this TOA. The T stands for tangent, and that equals opposite over adjacent. SohCahToa. The last one we're going to use is called the Pythagorean theorem. We use the Pythagorean theorem when we are trying to find side lengths. And it is a squared plus b squared equals c squared. So that's where we're going to start, the Pythagorean theorem. So back up here to our triangle. Let's say I'm given a side length for A is 4 centimeters. And the side length for B is 2 centimeters. So to find my hypotenuse, my side length C, I use the Pythagorean theorem. A squared plus B squared equals C squared. And just like in algebra, I put in some brackets where my variables are. So A squared is 4 squared. And then b squared is 2 squared. So a squared plus b squared equals c squared. 4 squared, 16. 2 squared, 4, equals c squared. So 20 equals c squared. And then I take the square root of 20. Grab your calculator, 20 square root. So my C side length equals 4.47. I need to make sure that that's the longest side length. So I have a 2 and a 4, so 4.47. I need to always carry through my units. So there's my answer for my hypotenuse side length. A squared plus b squared equals c squared. So let's do that again. Let's say I have a right angle triangle and I have two side lengths given. I'm going to start and draw my triangle. Let's say this time I'm given the hypotenuse is 5 inches, and I'm given a side length of B as 3 inches. A squared plus B squared equals C squared. I don't know A, so that's going to carry down. B is 3, and then C is 5. Sorry, that one's off the board there a little bit. So I'll have A plus 9 equals 25. Okay. So A squared plus B squared equals C squared. So then to solve for A, I need to get A alone first. So how do we do that? A needs to be by itself on this side of the equal sign. So I minus 9 from both sides. So 9 minus 9 is 0. So A squared plus 0. And then 25 minus 9, A squared equals 16. Then I take the square root. A equals 4. So I have a side length of 3, a side length of 4, and then a hypotenuse of 5. Pythagorean theorem. Let's do one more. So draw your triangle. Put all your labels on. So remember, A squared plus B squared equals C squared. So let's say I have an A value of 7.5 feet. And I have a hypotenuse value of 15 feet. So I bring my 7.5 squared, replace the A. I don't know B yet. And then 15 squared replaces the C. Grab your calculator, 7.5 squared, 56.25 plus B squared, and 15 squared is 225. Okay, I need to get the B squared alone, so I need to get rid of the 56.25 on this side of my equal sign. So B squared minus 56.25 on both sides gives me 168.75. And then I take the square root of that. B equals 12.99. So let's check and make sure our hypotenuse is still the longest length. So 15 feet, 7.5 feet, 12.99, we'll round that up, 13 feet. Any questions on the Pythagorean theorem? Nope? Okay, so let's move on to the angles. Remember how many angles? All three, they add up to what for every triangle? So angle A plus angle B plus angle C will always equal 180 degrees. And if I know that angle C is always a right angle, so there's 90, so I know that angle A plus angle B will always equal 90 degrees. So let's say on this triangle I'm given a measurement for angle A. Angle A, let's say, equals 30 degrees. How do I figure out angle B? We call this the easy way. So 30 plus angle B equals 90. All right, so 90 minus 30, angle B equals 60 degrees. What if angle A had been equal to 47 degrees? equals 90. 90 minus 47. So angle B equals 90 degrees minus 47 degrees, which equals 43 degrees. That's our easy way to figure out what an angle is. Let's do one more. Say I have an angle B measurement of 71 degrees. What does my angle A equal? So angle A equals 90 minus 71 equals 19 degrees. So the three angles always add up to 180. Since C is always a right angle, I know A and B together will always add up to 90. So let's go and explain our SohCahToa. So we're going to put that back here on the board. So sine equals opposite over hypotenuse. You're going to definitely need to memorize these. Cosine equals adjacent over hypotenuse. And TOA, tangent equals opposite over adjacent. Okay, let's go back to our triangle. C. Okay, hypotenuse. Which is the hypotenuse side always? Okay, our little c side is always the hypotenuse. So now let's talk about opposite and adjacent. Opposite means directly across the triangle. So from angle A, I go directly across the triangle. My side that is opposite of angle A is this little a side. Sorry, this gets from bad to worse. So the little a side is opposite angle A. Adjacent means it is the side next to the angle. So my side B here is the side that is adjacent to angle A. I don't ever use side C as either the opposite or the adjacent. It is always the hypotenuse. So if I ask which sides are adjacent to angle A, the sides adjacent are B and C, but since C is always the hypotenuse, I will use little side B is adjacent to angle A. So how about angle B? Let's look at angle B. Which is the side of the triangle that is next to the angle B? It's not the hypotenuse. Is little a. And then directly opposite the triangle from the big angle B is the little side B. So now when we talk about opposite and adjacent, let's say I want to do the sine for angle A. So the formula for sine is opposite over hypotenuse. So starting here on angle A, opposite angle A across the triangle is my little side A. And the hypotenuse is my little side C. So the sine for angle A is the opposite over the hypotenuse. If I do the cosine of angle A, right, so the cosine is adjacent over hypotenuse. So the side that is adjacent to the big angle A is our little b side over the hypotenuse. If I do the tangent for angle A, so look at angle A. Which side is opposite, so across the triangle from the angle A is the little a side. And then adjacent to the angle A is our little b side. So there's our three trigonometric ratios, sine, cosine, and tangent. And depending on which angle we use, helps us to determine which side lengths we want to use. So let's do a bunch of examples here. Okay. SohCahToa. Okay. There's our 3. You have to remember those. Here's our first triangle. Let's say I am given a side length for A as 5 centimeters. And I am given a side for my hypotenuse as 7 centimeters. And I need to find out what my angle A measures. That's what we're looking for right here. Angle A. So which of these 3 ratios should I choose? I'm trying to find angle A, and I know the side opposite, and I know the hypotenuse. So opposite and hypotenuse are sine. So do the sine of angle A is equal to the opposite side, or the little a side, over the hypotenuse, which is the little c. So then I plug in what I know. Sine for angle A. I don't know angle A yet. My A side length is 5 centimeters, and my C side length is 7. You're going to use your calculator a lot today. So 5 divided by 7. So the sine of angle A is 0.7143. So I have 2 ways now to figure out what angle A measures in degrees. I can use my calculator, and the way I do that is I need to push the second function button. On ours, it's a yellow button at the top corner. I push second function, and then I push the button that says sine. And my angle is 45.5847. So we're going to call that 45.59 degrees. The other way I can figure out what sine is to go to my book. On page 179, we have what's called a table of trigonometric functions. The way to use this table is it's divided into 4 different columns: angle, sine, cosine, and tangent, and then it repeats angle, sine, cosine, and tangent. So I find the sine column, that's what I'm looking for, and I go down that column until I find as close to 0.7143 as I can. So at the top of the second column, I have a 45-degree angle, and the sine value is 0.7071. And then my 46-degree angle, the sine value is 0.7193. So that tells me it's between 45 and 46 degrees, which is what our calculator tells us. So I've just discovered that my angle A is 45.59 degrees. So what's the easy way to figure out what angle B is? Right, A plus B have to equal how many degrees? 90 degrees. So I can do that on my calculator and find out that angle B equals 44.41, or I can use one of these ratios, which is what we're going to do. So now angle B. Which information am I given in relation to angle B? I'm given the hypotenuse, I know that. Am I given the side opposite angle B or the side adjacent to angle B? Right, my little a side is the one that I know, and it is next to angle B, so that's the adjacent side. So I need to use the formula that has adjacent over hypotenuse. And that is cosine. So the cosine for angle B is the adjacent side, which is A, over the hypotenuse. Then I plug in what I know. So cosine for angle B. Adjacent side, 5. Hypotenuse side, 7. 5 divided by 7. So the cosine for angle B equals 0.7143. And same thing, I can use the second function on my calculator. So hit second function, then cosine. My cosine for angle B should give me 44.41, which is the same thing we get if we subtract 45.59 from 90. This is just a way to verify. Or I can go into my table on 179 and use the cosine column and find 0.7143. So the closest we're going to get to that is going to be between, again, 45-degree angle. My cosine value is 0.7071. And then my 44-degree angle is 0.7193 cosine. So right in between those, there's my angle A and my angle B. The nice part about trigonometry is I can always check myself. There's multiple ways to come to every answer, and I can go back and check it 2 or 3 different ways to make sure. So I found my angle for A and I found my angle for B. The only thing I'm missing is this side length of B. So let's figure out how we would find that. Again, there's lots of ways we can do it. What's one way we can find it? Very good. Pythagorean theorem. So remind us of what that is. A squared plus B squared equals C squared. Okay? So let's do that. I have an A squared. So 5 squared plus B squared. And then what's my C value? 7. 7 squared. So B squared equals 49 minus 25 is 24. And how do I get B alone? Take the square root. So we're going to call that 4.9. 4.9. So let's see if we can find that same value or fairly close to it using one of our trigonometric functions. So I need to find side B. Which equation should we use? Okay. So we're going to use angle A. So which is side B in relation to angle A? Is it the hypotenuse, the opposite, or the adjacent? Okay, it's the adjacent. So adjacent, we need to use cosine. So if I do the cosine of angle A, is the adjacent side over the hypotenuse. Okay. So let's use 45.59 as our A value. Cosine 45.59 equals the little b side, which I'm trying to verify, over the c side, 7. So to get my little b alone, how do I do that? Times each side by 7, right. So that will get rid of the 7 on bottom. So then I'll have 7 times the cosine of 45.59 degrees. So start inside your brackets again and type in 45.59 and then just hit cosine on your calculator, cosine, and it should be 0.699788029, and times that by 7, and I get 4.898. So we round that up, 4.9. So that's the same value that we got over here, 4.9, 4.9. Can you see how we can always go back and verify? So let's go back to the chapter. The bottom of page 164, and let's work through some of the examples they give us here.